Hello YouTubers and SSG followers. This is 11 charging procedure by the Bedini SSG circuit, and let me show you my measurement equipment. On this side you currently seeing the voltage of my charging battery and the amperage of the charging battery. I'm measuring here the current which goes to the charging battery. So I didn't charge it, I didn't start my system yet, but I show you my equipment first. On this side you have voltage meter of the primary battery and the milliamps of the primary battery. So each battery is equal of the manufacturer and the quality and the date. So let's start the charging procedure. You're hearing here now the self-oscillation noise. I disconnect one of the cables like this, then reconnect, and I can start my system. And I move one time the wheel and charging procedure goes. The voltage of my primary battery was like 12.50, so it is interesting because I did charge my primary battery to the full charge, like 12.65 or a little bit higher. But anyway, the interesting what happening currently and my interesting observation is after discharge of the charging battery. So another discharge procedure had followed, and I got the resting voltage on the charging battery like 11.97, and you see that the voltage of my charging battery, when the system is powered up, when the SSG circuit is powered up, it's charging my charging battery, but at the same time my primary battery have a discharge, and you clearly see the milliamps in the voltage level of my primary battery. So it's like this, and charging procedure continues. I have 14 milliamps on the charging side, so it's pretty low current for this spinning of the wheel. It's not actually very fast spinning, but it's fast enough to produce short but very powerful radiant impulses, which you possibly saw in my previous videos about the SSG measurement. I did connect my oscilloscope, my cheap oscilloscope here, and I observed the impulses which are going currently to this charging battery. The charging battery was previously discharged to the level 11.97 like this, and actually it was discharged even lower, 11.71, but the resting voltage on the charging battery is 11.92. So what I should tell you next, which type of the discharge procedure I use. I have one device, it's a conventional solar panel charging device with protection for the undercharge and overcharge of the battery. So when I put the load onto the device and on the other side I connect the battery, I have controlled discharge procedure on the battery which I want to discharge. So, and you clearly see that the level voltage in my charging battery is pretty increasing, but I should always tell you this is in regards to the thing that I use the device which is used, the result which I have here currently is depends on my discharging procedure. So I put 250 milliamps for discharging procedure, and of course discharging procedure I do separately from the charging procedure which you're currently observing. So this is my charging procedure, and discharge procedure happens separately from this SSG circuit, and it happens sometimes more or less over the battery capacity, and I do the calculation in the Excel table. So once again, one important notice which you should take: this is not an over unity system. Why it's not an over unity system? Because the power which I get, I don't use it in the same time. So this primary battery always charged conventionally. This is a 12 volt 5 amp hour battery, and this battery charged conventionally, but at the same time my charging battery, I observe from step to step, from charging and discharging of the charging battery, I observe the voltage increase. So it means each time when I discharge the battery, I get more and more volts. And of course people say volts means nothing, and I agree with you, and I can only say this battery is in good shape. I don't see any sulfatation on this battery. This is a open lead acid battery. I can open, you see there are 3-6 openings which I put distilled water when I need to, but I see that charging is currently better, but the milliamp, the current which I spent, is always the same. This is thing you should notice my current which I get to charge the battery. So normally, for people who watching this video for the first time, normally to charge to the full capacity this battery 12 volt 5 amp hour battery, if you want to charge this battery to full capacity, you need like 200 and 300 milliamps conventional current to charge this battery to the full capacity. But which current I get, it's even less than 200 milliamps, but anyway I'm producing enough impulses. Why I speak about impulses? Because impulses actually what is actually charging the battery. This is, just think about, this is another type of the energy type. I know it's not very convincing, but let me show very quick one thing. On this circuit which you're currently seeing, you have one transistor, 2 diodes, the resistance 2003 ohm, and one neon light bulb. It's light up when 230 volts are passing through. It's like a protection for the circuit. So let me just show you following. I disconnect one of the connections to my battery from the SSG circuit, and nothing happens. It was wrong cable, sorry. I disconnect this cable, and you immediately see how this immediately see how the light bulb is lighting up. So this is actually an indicator that I getting with my circuit some type of energy, but it's not conventional type of energy, because you cannot see this on this cheap, I will say cheap milliampere, digital ampere meter. Sorry guys, I'm not English speaker person, but I'm doing my best. So what is actually happening? I will always repeat this question because it's a very important question. On this side you see that I power this system with a 28 milliamps. So this is my costs to run the system, and this is actually, I cannot see this pretty well. Let me just bring more light. I have here 12.41 volts on the primary battery. And so where was my thought of train? I mean, thoughts of train. My idea to explain to you what is actually happening here. Let me zoom on the wheel. Each magnet on the wheel is a north pole. So the north pole passing through the coil, over the coil. Sorry guys. And two magnetic fields collapse with each other, and this collapse produce for the short time impulses, which are triggered by the actually when the field energy, when the magnetic fields are collapsing in the coil, the transistor short circuit and it produces some type impulses, and this type of impulses I using to power my charging battery. The impulses are actually zero from one of the if you think conventionally, you probably say these impulses which I produce, they are actually zero, and I think it can be for one of the side of the science can be true, because I can not measure the milliamps in the impulses which I get, because it's very fast and very high impulses, so on the high frequency. And maybe if I have more expensive equipment, I probably if I have a lot of time to study this, maybe I catch these impulses on better equipment, and so how powerful such impulses are. They are. So anyway, charging of the battery happens, and it was explained like by Mr. Peter Lindemann, who was a partner and is partner from John Bedini himself. This guy, this man, scholar I would say, he explained that impulses which I produce with my system, they are driving ions in the battery plates, and these ion movements in the battery plates are actually moving to that level that the battery charging. So when you put the current to the battery, it's just like chemistry a little bit and movement of the ions in the battery. So if you do not understand what I mean, just go to the Energy Science forum, and you will find there a lot of very interesting and important information about this project. I can only say on my side, this is actually happening, the charging of the battery happening. This is a real current after all, and real watts which you can spend on some of the devices. But anyway, where it's going to which goal it's going to. So as I said earlier in my video, this is 11 charging procedure. I have another 9 charging procedures, and after the 20 charging procedure, I will try to utilize the charging battery to charge my primary battery. After this, probably I will report how it goes, what the problems, because you have in any case losses in the system. This is not, I think this is not, my build is not one of the successful builds. I mean, not the optimized builds which you can actually build with the Bedini, because I have here cables, I have here connections to each of the circuit elements, which next, when I build the next project, probably I will try to use some industrial circuitry and some more or less tested equipment, and I feel it will be better quality. And another thing which I told you earlier, it's magnetic field which is currently created by the coil. My coil is winding up with a clockwise mode, and better results you probably achieve with a counterclockwise mode. So if you wind the coil counterclockwise, you should probably get even better results, because you have more attraction force and then repulsion force when the fields are collapsing. So if you build this project for the first time, just wind the coil counterclockwise and use Lincoln rods R16. And the reason behind this, because these rods have important qualities for the coil core. And just look at my previous videos where I show you difference between some of the rods which you can and you cannot, which you can use and shouldn't use for this type of the project. And what I should tell you again, once again, this is not over Unity system, but it's very interesting way to charge the battery. And for this type of the project I recommend and advise to use not sealed lead acid batteries. Sealed lead acid batteries, they have some problems. Why? Because the liquid in the battery, it disappears from charge to discharge procedure. So, and if you will use any battery with sealed lead acid battery, you probably get to the same conclusion that it's very difficult to absorb the liquid in the battery. And I always monitor the liquid in the batteries, because if your liquid is not cover the plates, so it means you won't able to get better charging results, even with the conventional type of the charging. And for this type of charging, you need to control the level liquid in the batteries. So I just recommend spend more money for buying very good open lead acid batteries, and you will probably get even better results. But anyway, it's very important to use the right type of the batteries for this type of the project, and the coil itself. So it's charging pretty well for me like this. This is currently running on one transistor system. I can only imagine the level of charging when I use more than one transistor, because when I was able to set up the system for producing 14 charging impulses, radiant impulses. But if I got even more transistors for this type of system, I will actually able to capture a lot more radiant impulses. So I guess if you have 4 or 5 or 6 or 7 or more transistors, and you actually know how to set up the system, you probably gain a faster charging rate than I. But important is to know that you should spend less energy to charge battery. So you see for yourself, I spent 12-14 milliamps, and look at the battery, and the battery charging level is currently at 12.07. So something charging process happening, and yeah, it's like this. But anyway, do my research, and it's not finished research. Want to maybe what I should tell the world. Okay, primary battery. It's good to know to control the voltage level of the primary battery. So I guess I should, for the people who's just building this for the first time, probably I will recommend you to find the circuit which actually monitors the voltage level of the primary battery, and just disconnect the circuitry from the primary battery when the battery reaches the critical voltage level. It probably saves you a lot of time and pain. because you should able monitor the voltage level of these two batteries, and probably you will get even better results when you observe and know when to disconnect the system and reconnect once again. So anyway, 26, 29 to run the system, and 30, 39 to charge the system. The voltage increasing, so I'm at green. It's like this. So once again, not a Unity system, but pretty close to this type of the system. What should be done next research, it should be thought about automatization of the system, voltage observation and control of each type of the battery, and just then random experiments until you get some interesting result. This is only what I can observe and thought nowadays. So thank you all, and do the experiments. It's pretty overwhelming. Thank you all. Bye bye.